Welcome to the MOOCs course Mechanical Unit Operations. The title of this particular lecture is Size Enlargement Equipment. So, we have already seen the requirement of size enlargement. Why should we go for a size enlargement of the particles? Fine particles, we have seen that they are very difficult to handle and then they are very difficult to convey from one level to the other level. One of that reason, and another reason is that they are also having kind of health hazardous to the people working around or handling these kind of particles. So, there are other issues are also associated with the fine particles. Considering all those reasons, what it has been decided, rather having glidance etc., which may allow the flowing of the particle even fine particles also comfortably. So, it is better to optimize the particle size, optimize particle size, so that you don't need additional glidance etc., and then you can handle these fine particles comfortably, right. So, then in this consequent we have also realized the importance of the size enlargements. We have seen the methods of size enlargements, how the size enlargement takes place, like something like agitative agglomeration, which is also known as the granulation, or granulation is the process where agglomeration of the particles takes place, and then size enlargement, because of that one size enlargement takes place due to the agitative action imposed by external forces, something like that. Okay. So, other process that we have seen, like sintering is also one kind of a size enlargement process or method, and then we have also seen that pressure compaction is also a kind of one of the size enlargement method. We have also seen the kinetics or the different processes associated with these fine particles when they are combined with fluid, or when they are flowing along with a fluid, or if bulk fluid is flowing carrying this fine particle, then what kind of processes are available, that perikinetic, orthokinetic processes etc., we have already seen. So, now this particular lecture, before going into the details of the equipment under each and size enlargement methods, we will be seeing the listing out those kind of equipment, what are the different types of equipment available for size enlargement, and then what are their capacity, applications etc. Then we will be discussing the working procedure of some of these size enlargement equipment using their schematics. That is what we are going to see now in this particular lecture. So, tumbling granulators by name the granulators in the sense the size enlargement or agglomeration is taking place because of the agitative action, some kind of agitation is imposed. That agitation here is taking place because of the tumbling of vessel in which the agglomeration is taking place. So, that is the reason they are known as the tumbling granulators. We have two different types of methods available, or the designs available under these tumbling granulators. So, one is the drum granulator, another one is the disc granulator. They are good enough to produce product size between 0.2 to 20 mm. Product size here in the sense the enlarged product, whatever the enlarged size particle is there, or after size enlargement whatever the particle size is there, that is product size. So, enlarged particles, now in this context we are referring it as a kind of product. Okay, it is not a kind of some product of a reaction. Product here in the sense whatever the enlarged size of the particle is there, that is the product size. So, size enlargement is a process. So, size enlarged particles are a product. So, these tumbling granulators are good enough to producing granulators or granules of size 0.2 to 20 mm. The granule density or density of the agglomerated particles or granule is in general moderate. The tumbling granulator having the advantage of a high capacity, they can handle up to 800 ton per hour as well. And then the granules, after the size enlargement, whatever the granules that you get, they are very spherical in nature by using this tumbling granulator. So, whatever the granules that we get by tumbling granulators, they are very spherical in the nature. Then after the granulation or size enlargement, this particle in general has to be dried, that is also a kind of requirement. So, the drying of these granules in general done by the fluid bed or rotary kiln drying. Application of these tumbling granulators in general we find in fertilizers, iron and other ores, agricultural chemical processing etc. So, in the production of fertilizers, iron, other ores, agricultural chemicals, somewhere we need to have a kind of a enlargement of the particles. So, those enlargement of such kind of products in general one can use these tumbling granulators. The next method of size enlargement equipment is mixer granulators. So they are also granulators, that is the agglomeration is taking place by agitative action, right. So these mixer granulators can be of two types, continuous high shearing or batch high shearing equipment. Continuous high shearing mixer granulators in general produce the product of size 0.1 to 0.5 mm, whereas the batch high shearing mixer granulators can produce product size up to 2 mm, that is 0.1 to 2 mm. The density in general low if you apply the continuous high shearing mixer granulator. If you apply the batch high shearing granulator, then the granule density in general moderate. The capacity wise, continuous high shearing mixer granulator can handle 50 tons per hour, whereas the batch high shearing mixer granulators in general can handle 500 kg a batch, up to that capacity they can handle. So these mixer granulators in general handles cohesive materials, both batch and continuous, as well as the viscous binders and non-wettable powders. For all these categories they are suitable. Whereas coming to the subsequent drying processing, fluid bed, tray or vacuum, microwave, on-pot drying methodologies can be applied. These mixer granulators in general we find applications in production of several chemicals, detergents, clays, carbon black, pharmaceuticals, ceramics, clays, etc. So mostly the pharmaceutical, ceramics, clays in general, batch high shearing mixer granulators are used. The next method of size enlargement is fluidized granulators. So fluidized granulators, under the fluidized granulators we have three different types of methods available. One is the fluid beds, another one is the spouted bed, and then third one is the Wurster's coaters. So they are not only for size enlargement, these fluidized granulators are also used for a coating or layering kind of applications. And these fluidized granulators in general good for producing product of size 0.1 to 1 mm, and then their granule density is in general low if they are used for the granulation or agglomeration, right, and whereas their density may be moderate if they are used for a layering or coating kind of applications. The capacity in general batch wise they can handle 100 to 900 kg, whereas in a continuous mode they can handle 50 tons per hour. These fluidized granulators in general flexible and relatively easy to scale, however they are difficult for handling non-wettable powders and viscous binders. They are good for coating applications, and then the required drying or air requirements etc. can be handled in the same vessel. Such kind of fluidized granulators we find applications in continuous mode. If you are operating them, fertilizers, inorganic salts, food, detergents etc. in their processing, we may be using this fluidized granulator. The same fluidized bed granulator in the batch mode in general used for the nuclear waste, agricultural chemicals, pharmaceuticals. Next method of size enlargement is the centrifugal granulators. So here also they are granulators because the agglomeration is taking place by agitation. Agitative action is causing a kind of agglomeration, granule formation. So and then here in the under the case of centrifugal granulators, centrifugation forces are the kind of ones which are providing required agitation, right. And these granulators, centrifugal granulators are good for producing products size between 0.3 and 3 mm. Granule density in general moderate to high. The capacity is up to 200 kg per batch. They are in general used for powder layering and coating applications. For the drying requirement, fluid bed or same pot drying can be done. The chemicals are where we in general find the application of this kind of centrifugal granulators are in general for production of some pharmaceuticals chemicals or agricultural chemicals etc. There we in general find these applications of these centrifugal granulators. The next method of size enlargement is the spraying method. Under the spraying methods we have spray drying and then prilling as well. Product size distribution by spray drying is between 0.05 to 0.2 mm, whereas the prilling, the size distribution or the product size distribution in general 0.7 to 2 mm. under the spray drying, or by using spray drying one can obtain low granule density, but by using the prilling the moderate density granules are in general obtained. Morphology of spray dried powders can vary widely, and then in general same vessel can be used for the drying of these granules as well. Coming to the applications, spray drying methods is in general used for instant products, something like instant foods, dyes, detergents, ceramics, pharmaceuticals, whereas prilling methods in general used for urea and ammonium nitrate plants. The next method of size enlargement is the pressure compaction. There are in general several types of pressure compaction is possible: extrusion, roll press, tablet press, molding press, pellet mill. The product size by extrusion is in general more than 0.5 mm, whereas the roll press produces the products of size greater than 1 mm, tablet press in general of size 10 mm. Right. The density of the granules that are produced by pressure compaction is in general high to very high, whereas the extrusion can handle the capacity up to 5 tons per hour, whereas the roll press 50 ton per hour. On the other hand, tablets or tablet press 1 ton per hour is their capacity. Because tablets etc., these kind of things are specified amount of material, specified sizes are there. After compaction, pressure compaction, the product whatever you get, so in general you get very narrow product size because they are very spiced. So the compaction devices are very specified in size, so whatever the material comes in there and then get compressed and form as a kind of tablet or briquetting kind of things are there. So they are very specific in size, so very narrow size distribution one can get, and they are very sensitive to powder flow and mechanical properties. Then often subsequent milling and blending operations are required under this kind of pressure compaction process. Applications: pharmaceuticals, catalysts, inorganic and organic chemicals production, plastic reforms, metal parts, ceramics, clays, minerals, animal feeds are some of the kind of applications where we can find the usage of such kind of pressure compaction. Then next method of size enlargement is sintering, which is a kind of thermal processes. The product size in general 2 to 50 mm, granule density in general high to very high. They can handle the capacity up to 100 tons per hour, and then strongest bonding is the one of the primary feature of these sintering processes. Applications in general we find in ferrous, non-ferrous ores, cement clinkers, minerals and chemicals productions etc. The last method of size enlargement is liquid systems, where immiscible wetting in mixers or soluble processes, pellet flocculation are a kind of some type of size enlargement methods coming under liquid systems. They produce the product less than 0.3 mm in general, granule density is low, and then capacity is up to 10 ton per hour. The wet processing based on flocculation properties of particulate feed, subsequent drying is taken place in general. The applications we find by using these systems in coal fine, soot and oil removal from water, metal dicarbide, silica, hydrogels etc., waste sludge and slurries etc. And processing some these kind of materials, we often may need some kind of liquid systems where this kind of size enlargement processes or methods are involved. Now these are the size enlargement methods. Now we one by one we see some more details of our working process of this equipment. Let us start with tumbling granulators. In tumbling granulators, particles are set in motion by the tumbling action caused by balance between the gravity and then centrifugal forces. So there will be a kind of vessel which will be rotating actually, which will be rotating. So when they are rotating, there will be kind of some amount of centrifugal force, and then they are in the rotation, the particles move up. So then after moving to the top, they may fall down, same as in ball mills or something like that. So their size reduction is taking place here. Some additional binders are added together so that the fine particles are being granulated. So both centrifugal and then gravity forces may be acting. So accordingly the optimum speed should be used. So those details we are going to see now. So in general, in this kind of tumbling granulator, this is what happens. The fine particles are set in motion by the tumbling action caused by balance between gravity and centrifugal forces. And most common types of tumbling granulators are two, disc granulators and drum granulators. Generally they operate in continuous feed mode. The most important advantage of this tumbling granulator that they can handle large scale, I mean they can run in large scale with throughput up to 100 tons per hour, even more as well. Further, they produces granules in the size range of 1 to 20 in general, and they are not suitable for producing granules less than 1 size, because there is no control of granulation process in general in this kind of tumbling granulators. They are very difficult to produce highly porous granules, because in this continuous process or batch process, the spray drying of some solutions or binders would be done. So, these when these particles coming together, because when they come in contact with the binders, this whatever the interstitial spaces between the particles are there, those particles in general be occupied thoroughly efficiently by this binding material. So, because of that one, the porous structure, getting porous structure is a bit difficult by using these tumbling granulators. The tumbling equipment are also suitable for coating of large particles. First of all, they are not suitable for producing small size particles from fines. They are suitable for producing larger size particles like up to 20 something like that, and in addition to that, they are also used for coating such large particles. However, as I already mentioned, first of all they are not suitable for producing the smaller size particles, and then it is not possible or very difficult to coat such small size particles. So, difficult to coat small particles, as growth by coalescence of seed particles is hard to control in tumbling granulators. In tumbling granulators, controlling the consolidation process, coalescence and then granule formation and then consolidation of those granules is very difficult to control in general. That is the reason the product size that we get from these tumbling granulators is in general very large, up to 20 20 is a kind of large size, considered under large size particles. So, now we start with the disc granulators. So, one of the industrial disc granulator is shown here. So, here this disc, this circular disc whatever is there, that in general rotates in onto which the particles are coming from here somewhere, and then these are the kind of from here some amount of liquids or binders are in general sprayed. So, these particles whatever are coming here, so they will be mixed with these solutions, and then this rotates in a kind of direction like this. The granulator disc granulator rotates in this direction. So, the mixing of these particles and then binding solutions takes place, and larger particles are in general taken as a kind of product from somewhere here, whereas the undersized particles, now undersized particles are not the products, they are kind of rejected material. So, they will be sent back into the process after recycling, so that they will be further granulated. So, this is the general kind of process, but this disc granulators will be seeing the schematic of the same thing once again in the next slide. Right. These disc granulators have been given different names in different industries. Let us say it is known as the pelletizer in iron ore industry, whereas in agricultural chemical industry it is known as the pan granulator. Equipment in general consists of a rotating tilted disc or pan with a rim, whereas the solids and wetting agents are continuously fed or added to disc, and then granulated products are taken continuously from the bottom of the disc. So, schematic if you have, so let us say as the the disc that I was mentioning, the previous slide whatever the industrial scale disc granulator is shown, so that has been redrawn for a kind of clarity here. So, there is a kind of disc kind of thing is there, so which will be rotating in this particular direction like this. Okay. So, there is a kind of concentrated solution chamber is there, or bins or containers are there at the top. So, they can spray these solutions continuously, right. So, the particles are also coming continuously here, right. So, these particles whatever are there, continuously fed particles, they mix with the kind of solutions or binders that we have been used. Once the particles of sufficiently large size are there, product size are there, they can be taken as a kind of product from here at the bottom, whereas the undersized particles or rejected particles, they will be taken to the recycles, and then from recycle bins they will be again added to the process, and then this process continues until the desired degree of size enlargement taken place. Right. So, there is a kind of scraper which controls which is useful in controlling the size of the granulator as well as the whatever the solution being added. So, those controlling can be done, or the size classification can be done by this reciprocating scraper which is moving mechanically. Now, the frontal view of the same equipment, if you see, so this is a kind of disc here we are having, right. The feed and then wetting liquid is coming continuously here. So, here this disc rotates something like this in this, let us say in this direction, it may rotate the other direction also. So, when it rotates, then whatever the feed in the sense small size particles, right. So, they will be mixed with the binders, and then a kind of enlargement will take place, and then agglomerated or enlarged particles will be collected from here for the further processing if at all required, or if it is last stage, then they will be collected as a kind of product. In general, they are taken to the further processing because they have to be dried as well, right. So, this is what about the disc granulator. So, what happens here, whatever the coating of feed material is there, that builds up on the disc. Thickness of this layer is controlled by the scrapers or a plow which oscillates mechanically. Surfaces of pan may also be lined with expanded metal or an abrasive coating to promote proper lifting and cascading of particulate bed. So, on the pan we have in general, so let us say this is the pan. So, there will be a kind of a metal lining or kind of cascading kind of things are available or provided, so that this proper to coat the proper lifting and then cascading of the particulate bed, etc., that is possible, or that would be enhanced because of this cascading metal lines. Okay. Solids are typically fed by either volumetric or gravimetric feeders. So, both way they are possible. However, the gravimetric feeding improves the granulation performance due to smaller fluctuations in feed rates. Wetting fluids which promote growth are applied by series of single fluid spray nozzles distributed across the face of the bed. And then solids speed, at what speed solids are entering, and then location of spray nozzle locations, they are going to have a kind of significant pronounced effect on granulation performance and granule structure, because the feed should not be coming at very slow rate, so that the most of the binder is large amount of binder as the solution is coming, and then when they are mixing a kind of slurry is taking place rather than kind of granulation is taking place. So, that should not be there. Similarly, solid should not come in at very fast rate, otherwise without being granulated the particles may be leaving from the container, etc. And then spray nozzle location also, it should be such a way that most of the spray is coming into the contact with the incoming feed materials to the maximum possible level. So, that is the reason the speed at which solids entering and then location of the spray nozzles used for the spraying this binding material, etc., is going, both of them are going to have a kind of a very strong effect on the granulation performance and then granule structure that are being produced after the process. A required disc rotation speed is given in terms of critical speed. In general, there is a kind of critical speed for rotating this disc, because if the speed is the rotational speed of disc is, if it is very small, what happens, the particles may be sliding over, right. If the rotational speed of the disc is very large, then may be particle thrown out of the disc. So, both of them are not required. So, that is the reason there should be a kind of a critical speed of rotation for this disc granulator. So, the disc should be rotate below that critical speed only. So, how do you get that critical speed of that particular process in general? When you equate the forces on the disc granulator because of the centrifugation and because of the gravity. Whatever two forces are there, if you equate them and then simplify those equations, then you can get a kind of equation for the speed of the granulator. So, that speed of the granulator, rotational speed of the granulator is known as the kind of critical speed. So, that is the speed at which the centrifugal force is balanced by the gravity force. And then that equation we can see here, NC is equals to square root of G sin pi by 2 pi square D, where pi is a angle of disc horizontal to the plane, because we know these disc granulators are in general not on flat. So, they are making some kind of angle when they are mounted on a horizontal surface. That at what angle they are mounted, that is known as that angle of disc to horizontal plane, and D is nothing but the diameter of the disc. So, in general, typical operating ranges for disc granulators is 50 to 75% of critical speed, and then disc angle should not be more than 45 to 50 degrees. If the speed is too low, as I mentioned, sliding of the particle will occur, and then if the speed is too high, then particles will be thrown off the disc in general, as well, as I already mentioned. So, that is the reason we need to have a kind of proper speed or critical speed. So, that should not be too smaller than the requirement, that should not be too larger than that critical speed. Otherwise, if that is too smaller than the critical speed, what will happen? The particles may slide over. Okay, sliding of the particles may take place. If the speed is larger than this critical speed, then centrifugal forces may strong dominating, and then particles may be thrown out of the disc. So, both of them are not required, they are not good for the efficient operation of such kind of processes. Next one are the drum granulators. The mechanism physics is almost similar to whatever we have the disc granulator, but here the difference primarily is that we have a kind of cylindrical vessel. Okay. There in the disc granulator we have a disc, rotating disc, on to which the feed and wetting fluid is coming. Now, here we have a cylindrical drum kind of thing, in which the feed material as well as the binding solutions are fed according to the required flow rates, etc., and then the cylindrical drum is rotating so that the granulation takes place. Right. So, we will see some details of these drum granulators as well now. They are very common in metallurgical and fertilizers industries. It consists of an inclined cylinder which can be either open ended or fitted with annular retaining rings. There are different rings are possible. We will be seeing that schematic. So, that will enhance the degree of the granulation in general. Feeds may be either pre-moistened or pre-mixed by the binding material by which we are going to form the granule nuclei, or liquid may be sprayed onto the tumbling bed via nozzles or distributor pipe system. Drums are tilted longitudinally a few degrees from horizontal, 0 to 10 degrees, to assist flow of granules through drum in general. So, a schematic of rolling drum granulator is shown here. So, we can see, so this is a kind of a cylindrical drum. So, two ends of this cylindrical drum is shown here, something like this. They are connected some like this, right. So, they are having their kind of rings, whatever the internal rings they are mentioned. So, their kind of rings are also possible. So, the material comes through here. So, the material solid feed comes through the chute from here, and then there is a distributor pipe system through which this liquid is being sprayed, the liquid or the binder which is used for agglomeration here. So, they are sprayed here through this distribution pipes like this, right. So, when the particles comes here and then interact with the sprays, and then this drums rotates in either of the direction it is possible. Let us say that rotates in this particular direction. Then mixing of these binders and then fine particles will take place, and then these fine particles will form a kind of nuclei granules. So, these granule nuclei are further coalesce and then form a kind of a bigger size particles. That process takes place inside the drum. When this drum rotates, drum is already having the feed solid feed that is coming continuously, and then binding solution is continuously sprayed onto that particle. So, they are mixed, and then kind of a required granules are formed in the inside this cylinder. So, these particles are inside this cylinder, they are kind of rings are available, or kind of fractionators are available. So, the particles moves from one level to the other levels, and then whatever the particles, the product are there, they are taken from this exit chutes here, whereas this particular whatever shown here, this is known as the kind of exit dam ring. Like that, several rings are there in between. So, this is in general the way how the rolling drum granulator operates. The working principle, working process looks similar, but its design and all that is going to be properly managed in order to have a proper granulation. So, in these drum granulators, there is also a kind of scraper bar which is going to control the granulation process, or the amount of liquid coming and then amount of the solid feed, that is those kind of things are being controlled by this scraper bar. So, critical speed equation for this drum granulator is exactly same as the disc granulator, but pi should be in between 80 to 90, because they are slightly inclined or longitudinally oriented slightly from the horizontal. So, that slight degree is only up to 10 degrees only. So, that is the reason pi has to be 80 to 90 degrees. And then to achieve a cascading tumbling motion of the load, drums operate typically 30 to 50% of the critical speed, whereas the hold up is up to 10 to 20% of the drum volume, and then 1 to 5 minutes residence time is common and sufficient in general in order to fulfill a kind of a granulation operation in drum granulators. Now, effect of operating variables on granulation rate processes, especially for these tumbling granulators etc., that we are going to see now here. So, in general these granulation rate processes are same as stages in agglomeration rate processes that we have already discussed. However, in tumbling granulators the growth processes are complex for a number of reasons. So, why they are complex? We see a few of the reasons. First of all, granules remain wet and then they can deform and consolidate. So, what does it mean? The behavior of a granule is a function of its history. So, whether it is wet or deformed or consolidating, or how much it has been wet, all those kind of things are going to show a kind of influence on the final granulation process. Then different granulation behavior is observed for broader and narrower size distribution of the feed material. If the feed material is having very narrow size distribution, then different granulation behavior is seen. If the feed distribution is having very wide size distribution, then the granulation behavior is found to be very different from the other case of narrow feed size distribution. So, this is another reason. And then often growth mechanism compete. Actually, often complex competition between growth mechanisms have been observed. So, that is the other reason. So, because of these reasons, the growth processes are found to be a kind of complex, especially in this kind of tumbling granulators, that is disc and drum granulators. Next, consolidation of granules. So, consolidation of granules in tumbling granulators directly determines the granule density and porosity, because there is no in situ drying to stop the consolidation process. Here when we use the drum or disc granulator, the subsequent drying process in general has to be taken care by some other fluid bed or rotary kiln dryer kind of things one has to use, because in situ drying of these granules is not possible in tumbling granulators. Because of that one, consolidation process continues and it is very difficult to control. So, that is the reason granules consolidate over extended times. Further, increasing size, speed and angle of drum and disc will further increase the rate of consolidation. So, if you plan to have a kind of bigger size equipment in order to you can have a kind of handle larger capacity material, then it is also possible that by having such big equipments you may you may be increasing the consolidation process. And then similarly, speed also, if you go more than 50% of the critical speed, then again the consolidation may be a severe problem. And then angle of drum also, you cannot have a larger angle drums, they should be up to 10 degrees only, up to 10 degrees from the horizontal, otherwise again consolidation will increase. Further, increasing time through lower feed rates will increase the extent of consolidation. And then in the case of disc granulators, residence time can also be increased by increasing the bed depth, raising disc speed, or lowering the disc angle. In the case of drum granulators, residence time can be influenced by the internal baffling. Internal baffling or baffles we can have, like in general we have a kind of in mixers or the continuous mixing equipment where the reaction may also take place. So, we in general what you do in order to enhance the mixing, we have a kind of baffles. So, such kind of baffles may be arranged inside the drum granulator. So, when you have these baffles in the drum granulators, the residence time will again be increased. Next is effect of moisture content in growth rate. How much liquid should you give for a given fraction of material, solid material. So, that is or for a given liquid density and for a given solid density, how much liquid should you use for a given operation of the granulation process is also a kind of a very important factor. So, we will see first what are the effect of this moisture content, and then we try to build up an equation for that moisture content. Growth rate or the size enlargement rate is in general very sensitive to liquid content for narrow initial size distributions. With increase in liquid content for fine powders, leading to an approximate exponential increase in granule size may take place. For lower viscosity liquid, granulation occurs when very close to the saturation of the granule. This leads to the following equation to estimate the moisture requirement. Omega is equals to epsilon rho L divided by epsilon rho L plus 1 minus epsilon rho S, where omega is the weight fraction of the liquid, rho L is the liquid density, rho S is true particle density, whereas epsilon is the porosity of the closed packed material. What is the porosity? That is the interstitial spaces whatever is there of the packed material before the granulation. So, that is epsilon. So, how much, let us say you have the 100 kgs of the feed material, and then let us say you have the moderately viscous liquid whose density rho L is 1000 kg per meter cube, and then true density of the fine particles that you are going to agglomerate, that let us say it is having 1600 kg per meter cube, and then when initially when this particle is taken into the inside the granulating equipment, the porosity of that material or in volume fraction of interstitial spaces is epsilon. Then using this equation you can know what fraction of liquid should you use. If this comes out to be, let us say 0.2, that means 20% of liquid should be used based on the whatever the initial solids that you have taken. If you take to more than that one, it may be a kind of a loose slurry kind of thing, material may form, and then granulation may not take place. If you take very smaller than this quantity of the liquid, then again the proper granulation may not take place, indeed only partial granulation may take place. So, that is the reason the effect of moisture content is also going to have a kind of very strong role on the size enlargement growth rate. Now, we see some relative merits and demerits of disc versus drum granulators. The principal difference between disc and drum granulators is the classifying action of the disc. The classifying action, the disc granulators are having a kind of classifying action that we have already seen. So, because of that one, you can control a kind of narrow size distribution of the particle, that is product size distribution you can manage to very close particle size distribution. So, because of this classifying action of the disc, one can get the disc granulators having narrower exit granule size distributions. However, on the other hand, Drum granulators produce denser granules than the disc. Control of growth mechanism on disc is very complex because regions of growth overlap and mechanisms in general compete each other. So, because of that one, finding out the or controlling the growth mechanism on disc granulator is very difficult, which we have already seen. So, because of this regions of growth overlap and mechanisms competing each other, so both layered and then partially agglomerated structures are possible in disc granulators. Rather than having a kind of proper complete granules, you may get layering of the particles or partially agglomerated structures you may get. However, disc granulator is having several advantages, which include that it is a low equipment cost. The equipment cost is very low and sensitivity to operating is under control, one can easily control, and then easy observation of granulation and classification action. So, one can easily observe the granulation process as well as the classification process, so that if anything goes wrong, one can make a kind of a necessary remedy or necessary action immediately one can take. Dusty materials and chemical reactions such as the ammoniation of fertilizer are handled less readily in the disc granulators, which is a kind of disadvantage, because in general these disc granulators may not be completely closed. In general they may be sometimes open also. So, because of that reason, so dusty materials and then chemical reactions like in fertilizers industries whatever takes place, where granulation is also kind of important process, it is not advisable to use these disc granulators. In such cases it is better to use drum granulators. Drum granulators having several advantages over disc granulators, something like the capacity is very high in the case of drum granulators, and then longer retention time for material difficult to agglomerate. It is not necessary that when we mix the material, the binding liquid and then fine particles of feed, you just mix and then rotate the drum, so then granule will take place. It is not like that. Some materials are in general very tough, very difficult to agglomerate. So, under such conditions you need to have a kind of longer residence time of this feed material as well as the binding material, so that the agglomeration properly takes place. So, that can be easily done using the drum granulators. Or sometimes poor flow properties are there. So, then also for such kind of materials also these drum granulators are better, and then materials less sensitivity to upsets in the system due to damping effect of a large and recirculated load, that is the other advantage. However, drum granulator is also having some kind of disadvantages, such as high recycle rates, which can promote limit cycle behavior or degradation of properties of product may take place because of this one. So, these are the kind of some disadvantage of drum granulators. So, both of them are having some kind of advantages or disadvantages. So, based on the applications or requirement, one has to make a kind of selection whether should one go for a disc granulator or should go for a drum granulator. So, blindly one cannot go for a any type of granulator. Finally, the references. The entire lecture indeed has been prepared from this reference book, Perry's Chemical Engineer's Handbook by Green and Perry. However, some details may also be found in this other book, Unit Operations of Particulate Solids, Theory and Practice by Ortega and Rivas. Other reference books are Colson and Richardson's Chemical Engineering series, second volume by Richardson and Harker. Then Unit Operations of Chemical Engineering by McCabe, Smith and Harriet, that can also be a good reference. And then Transport Processes and Unit Operations by Gian Coplis. Finally, Introduction to Chemical Engineering by Badger and Banchero can also be a kind of good reference book for the lecture that has been presented today's lecture. Thank you.